Welcome to GRE Snacks, snackable episodes about the GRE, GMAT, and graduate school admissions. I'm Tyler, the founder of Achievable, and we have an affordable GRE course that includes everything you need to ace your GRE exam. A full textbook, videos on key topics, tons of GRE questions backed by our memory-enhancing algorithm, a built-in study planner and essay grader, and full-length practice exams. You can try it out for free at achievable.me, and if you like it, the code podcast will get you 10% off at checkout. Now, let's get started. Today, we've got Erfun Guela with us. Erfun, I'd love if you could introduce yourself.
Sure. So I'm a professional GMAT and GRE tutor. I have a perfect score on the GRE, and previously I'd written and published a book through McGraw-Hill, the McGraw-Hill Guide to the GRE, which I've now self-published as the Ultimate Guide to the GRE, which you can find on Amazon, and you can find my tutoring services at grecompass.com.
Yeah, great. Well, and today we're going to be talking about quantitative comparison questions and just how to handle those, in this year of our Lord 2025. It has been covered a couple of times on this before, but not recently. So first, I think the first question is, let's just take it from the top for people who maybe haven't heard this yet. What are quantitative comparison questions and kind of how can you recognize them?
Sure. So quantitative comparison questions have a unique format on the exam. Essentially, they're going to provide you some information, and then they'll give you two quantities, quantity A and quantity B, and the goal of the question is to establish the relationship between the quantities. So if quantity A is larger, the answer would be A. If quantity B is larger, the answer would be B. If the quantities are equal, the answer is C. And if there's more than one potential relationship, the answer would be D, which essentially cannot be determined. One thing worth noting is that quantitative comparison questions will be at the beginning of both quant sections. So, first section, the first 6 are quant comparison, and second section, the first 7 are quant comparisons.
Got it. Yeah, and these are often considered kind of the most difficult of the quant questions on the GRE, right?
Yeah, they're a little bit deceptive. Some students kind of trivialize them. I actually think that they're easier because they seem simpler. But they are a sort of thorny spot for a lot of people if they don't prepare for them properly.
Right. Yeah, so let's take it from the top, right? So how do you prepare for them properly? I think that then we can talk about kind of maybe if there's any new trends with like this year's exams or with even this year's students that you're seeing. But first, like as a broad overview, kind of how do you tackle these?
Sure. Well, so the biggest thing to understand about quant comparison questions is looking at it from the perspective of the test makers, and the first point I want to make is understanding how long these questions, quote unquote, should take. So standard multiple choice questions should average about 130 seconds, so about 2 minutes and 10 seconds per question. Quantitative comparison questions are designed for you to average about 90 seconds per question. So there is a big discrepancy there. These questions should take less time than standard multiple choice questions. Okay, now that discrepancy in the time is going to inform your approach. The thing we need to reflect on is why are we expected to spend less time on these questions than a standard multiple choice question? That discrepancy is reflected in the fact that these questions are designed so that you don't need to do as much math as you would on standard multiple choice questions. If you think about the nature of these questions, they're not asking you to actually solve. They're asking you to compare. Now, this seems obvious, that's the nature of the question, but a lot of students don't really carry that fact to its conclusion, which is you need to be on high alert when doing these questions to minimize math as much as possible. One of the biggest issues I see with students when we review their ETS diagnostic. Now, that ETS diagnostic report is actually something we discussed in the podcast a couple of years ago, but it's basically a breakdown of your performance on the exam, and it gives you, both accuracy and also timing across the different question types and topics. And one thing I see with a lot of students, they'll tell me they had timing issues in quant. We'll review their diagnostic, we'll look at the averages and realize, wait a minute, you're averaging 2 minutes on quant comparison, you're averaging 2.5 minutes, there's a big problem. And again, that's reflected in the fact that most students come at quant comparison from the same lens that they come at standard multiple choice. They see that math is available, they start doing the math, and the question takes a lot longer than it needs to. So, the fundamental principle, like the overarching principle that I espouse to my students is you need to look at these from the lens of compare, don't calculate. In other words,
Right.
your first order of business should always be understand exactly what you're comparing, understand how they're similar, understand how they're different, and then examine those differences. Just because you can do a calculation within a certain quantity doesn't mean you actually should.
Mm-hmm. Got it. Yeah, and I think also in general, it's kind of just an overall rule, I think, for the quantitative section of the GRE is that if you can do it without math, do it without math, right? Like a lot of these are more logic questions anyway, but especially the quantitative comparison ones.
Yeah, absolutely. Exactly. And these are definitely, I mean, the very fact that they have these as separate from standard multiple choice means they're testing something a little bit different. And yeah, to your point, they are testing more your kind of logical reasoning within a quantitative context versus like actually being able to sit there and do the force math. And, I will say both just, personal experience, taking the exam, having reviewed basically every official question available. When I do any quant comparison question, if I find myself getting in the weeds in math, alarm bells are going off. It's just like, if they really care about me sitting there and doing that math, they would just put this in a standard multiple choice context. They're not doing that. There has to be a more efficient way to solve it.
Right. And so much of it is just like thinking about, what the comparison is they're asking and then trying to at least determine like, D, is it solvable or not? Right.
Yeah, for sure. I mean, that's a big component of it, just actually asking whether it is solvable. That's a situation where sometimes testing numbers in the right way would be helpful. But, equally importantly, I mean, the way I like to frame to students, and I actually stand by this, I do think to a large extent, quantitative comparison questions are about kind of scientific reasoning in the sense of when scientists conduct studies, they basically control all variables except for when they isolate a variable and then examine the differences between the two groups. That's what you want to do in quant comparison. Keep everything the same, isolate a difference, examine it. Pretend you're being a scientist as you work the question. That sounds a little bit weird, but that is a reasoning style that's rewarded in the real world as well.
Yeah, so like give me an example of that, I guess, or kind of explain that more, because I feel like that's really interesting. Like, I feel like that is exactly what I naturally do on these types of questions, but that maybe other people don't, where I'm immediately like, okay, where's a part of the problem where I could figure out something?
Yeah, obviously speaking about it's harder than showing it. But, an example would be, I mean, okay, if the audience can bear with me with this example, imagine something like quantity A has 4 fractions. The fractions are 1 divided by square root of 2 plus 1 divided by square root of 3 plus 1 divided by square root of 4. And then imagine quantity B is just 1 over 2 plus 1 over 3 plus 1 over 4.
Mm-hmm.
So, the quantity A is pretty ugly from a mathematical lens. I mean, you could theoretically do the radicals, calculate it, etc. But, obviously have fun with that. That's going to be pretty time consuming and error prone. So what we have to ask is, okay, if we're going to use the principle of compare, don't calculate, our thought process here should be, well, how are they similar? How are they different? Examine the difference. Okay, so first major similarity, we're adding 3 fractions in both quantities. Next major similarity, the fractions all have the same numerator. Next similarity, the 2s, 3s, and 4s, right? Those match up. The major difference is we're doing the radicals and the denominators of quantity A. So the real question we have to ask there is, okay, that's the fundamental difference. How does that difference affect the relationship? If I square root a denominator, what impact will that have on the overall outcome? Well, when we square root the denominator, it's going to make the denominator small. And the next question is, okay, well, if I make the denominator smaller, what happens to the fraction? And the theory here, smaller denominator is going to yield a bigger fraction. So we're able to conclude, okay, well, each respective fraction in quantity A is larger than each respective fraction in quantity B. Therefore, the sum in A is larger than the sum.
Right. And you didn't have to solve any of that, right?
Exactly.
Or even if you really felt like it, you could take away, okay, 1 square root 4 is 1/2, so you could cut 1/2 off of each, right? But like, even so, like, that's still not really the point of your example.
Yeah, exactly. You could do that, but I'd argue that's an example of just doing math because it's available versus having a
Right,
reason for doing it. Yeah. And that, again, that's like the
right.
kind of trap that you want to avoid. Because I mean, they design these to basically penalize people who do math without knowing where it's going to take them.
Right. Yeah, exactly. Yeah, so I guess then, like, what else haven't we covered in terms of like tips for solving these types of questions before we move on to kind of like what's going on with them recently?
Yeah, the other major tip comes uh, has to do with plugging in numbers. What I call testing cases. This is a strategy most people are familiar with, either intuitively or just based off some of their test prep. What I will say, most students either overdo it with testing numbers or they don't do it properly. Now, when I say they overdo it, what I mean is when you test numbers, implicitly that means there are variables in the quantities. And the thing is, when there are variables in the quantities, you do have an alternate strategy available. That strategy is to
Mhm.
treat the comparison like an equation and to manipulate it. Now, this is something for the listeners, you might want to like reference Achievable to understand the strategy I'm getting at because it's hard to fully elaborate on this just audio. But the idea is quantitative comparison questions. You do implicitly have a relationship, right? It's either they're equal, greater than, or less than. If you have a relationship, it's algebraic, which means if you do the same thing to both sides, the relationship won't change. So one strategy that's
Mhm.
available to you in quant comparison when you have variables is pretend it's an equation, manipulate it, isolate the variable. If you have x on both sides of comparison, play around, get x all on one side, get the numbers on the other side, and in doing so,
Right. Like treat it like a system of equations problem, basically.
not quite a system of equations. It's not that you have multiple equations. It's just that you have one equation. You're pretending the comparison is an equation, and you're manipulating it to simplify the comparison. It basically
Got it.
it makes the question easier to deal with. And the point is, if you're going to test numbers, generally the strategy of simplifying is also available, and that strategy is
Mhm.
usually going to be more efficient than testing. Okay, so that's what I mean by overdoing it. If you're going to test numbers, ask yourself, can I simplify? Usually you can. Usually it'll be faster. The other thing, if you test numbers, which sometimes you have to, make sure you're playing devil's advocate. When I say that, what I mean is the fundamental goal in testing numbers in quant comparison is to prove D. What you want is, to the extent possible, show that there are multiple relations between the quantities. If your goal is to prove D, you don't want to simply list out 5 different numbers and just blindly plug them in. You instead want to make sure that when you start choosing numbers, you're doing it with in the back of your mind saying, okay, well, I want the outcome of scenario 2 to contradict the outcome of scenario 1. So if scenario 1 gave you the outcome that quantity A was greater, your next step in plugging in your next number is to ensure you get an outcome where quantity A is not greater. That goal is going to
Mhm.
dictate the numbers you choose. So sometimes it might be you chose a positive, now you want a negative. You chose a fraction, now you want an integer, and so on. But make sure you're not just blindly plugging in numbers without knowing what outcome you're trying to.
Right. Yeah, and also, are there specific numbers that are more useful to try and break things, right? Like 0, 1, -1, all that good stuff.
Yeah, the quote unquote weird numbers. Yeah, like if you don't know where to go with the numbers, 0, 1, -1 are always great numbers to start with. And then you want to look at like splits between numbers. So if you chose a fraction, think of like what's the opposite of a fraction being integer, right? If you chose a
Mhm.
positive, what's the opposite of that? A negative. If you chose an odd, what's the opposite of that? It's going to be.
And also, even if you're saying, let's say you plug in -1 and 1, and you end up with 1, the answer is A is greater than B, and with -1, the answer is B is greater than A, then your answer choice is D cannot be determined, like right away, right? That's always one to kind of like, you're hoping it's that sometimes.
Yeah, exactly. That's the point of proof. Like your goal there is to prove D. That's why you want to make sure when you use a little bit of foresight when plugging in subsequent numbers to ask, okay, will this actually contradict the original relationship? Right? If your original relationship was that A is greater, you want to do your best to make sure the second situation makes it so that A is no longer greater.
Yep. Yeah. And then the other thing is, so with the new GRE being shorter, how important is it to like save time on these questions, right? To do it quickly.
Well, so in shorting the GRE, they haven't necessarily, for the most part, changed the distribution of time. It's still reflected the same way. Though I will say, the second section, the way they've constructed it, is quantitative comparison questions need to actually go a little bit faster than was the case before. You do need to average, from based off of the way I've estimated, around 80 seconds per question. Which is, again, all the more reason to make sure you're establishing, you're maximizing your efficiency on these. One thing I will say, with the shorter GRE that I've been advocating to some students who have difficulty in quant comparison is save the quant comparison questions for the very end. And the reason I suggest that is if you do, so quant comparison questions are presented at the beginning of the section. Sometimes psychologically what happens at the beginning of the section, everybody feels, so inclined to be thorough and make sure they're not making silly mistakes that they subconsciously spend way too much time on these QC questions. Whereas if you save them for the end, that time constraint might actually force you to look at these in the way you should be looking at them, a little bit more high level logically versus just force math.
Huh. That's funny. Well, and also, if you just kind of have that assumption going in, and train yourself, time yourself, basically, as you're doing your prep, then hopefully you can just get to that point anyway.
Yeah, for sure. I mean, obviously that is the ultimate goal there, right? Prep in the right way. Make sure you're timing yourself when you're practicing quant comparison. Reviewing them in the right way, with an eye toward what we've been discussing to ensure that, you're not falling behind on time.
Great. Well, and then anything else about sort of what's new with this question type in sort of the last year, or is it still pretty similar, but just, be more conscientious about it with the time change?
Yeah, fundamentally, it's still pretty similar. I mean, the major proportionally, these quant comparison questions matter more now than they did on the old exam because there's fewer data interpretation questions. So, studying properly for these will matter. And I will say, just for anybody who's struggling in quant, if you master quant comparison, those could be very efficient points you can make relative to spending 20 hours trying to study everything about probability or combinatoric, insert advanced quant topic here.
Yeah, it's going to be a decent chunk of the test, and also if you can get them right, you're actually going to save time for everything else, right? So that's a good reason.
Yeah, exactly.
Great. Well, thank you so much. This has been GRE Snacks, hosted by Tyler from Achievable with Erfun Guela from GRE Compass. And Achievable is a great online GRE course that you can try for free at achievable.me, and you can use the code podcast to get 10% off.